where yeah, I'm going to start. Where are my hold on, okay. I cannot find the window. Yeah, here it is. Okay, and let's continue our discussion. And if you recall, last class, we discussed the priority queue. Okay, priority queue. And we also discussed more on comparator interface, how to use it. And the example is regarding a priority queue on books, okay? And we explained the different scenarios and with different approaches. And if you recall, for the comparator, you can also do the chain the call with the comparing method. So comparing is the default method, okay, in comparator interface, because comparator interface is a functional interface. So it has only a single abstract method called compare. Okay, and we also discussed comparator interface is more flexible than comparable. Okay, so over here, then you can also specify like different criteria for your comparison. Is that in this case you first use ID, and when you use comparator, it's also quite flexible, is you can also just pass in some method as a parameter, okay? And you can also call then comparing, because comparing return a comparator. That's why you can chain the call, okay? And this is regarding priority queue. And if you recall, for our priority queue also notices a sequence of items in the queue. Prior is not always in sorted outer, okay? But whenever, so if you use that iterator and has next and next, the output may not be in the sorted order. Okay, so be careful about this. But if you call that remove from the front, then the output, like in this kind of a loop, then the output will be ordered. Okay, so that's just some little things in priority queue we needed to be aware, okay? And there is a little bit of leftover within this example. What the next one shows here is we have 4 strings, etc. And you can also just directly call array as a list, convert it to a list. And over here, we assign it to a list variable. Okay, and then over here, we create a queue. So this is queue. Okay, queue is first in, first out. Okay, so it follows the adding order, not like a priority queue. It's not exactly following your adding order. It's based on the priority. So for queue, we already quite familiar. As you cannot, because queue itself in collection, Java collection is an interface. You cannot use interface to create object. Okay, So over here, we use a linked list, okay, because a linked list implement queue interface. So it also support first in, first out. But what we plugged in is this sequence of items, is it? And then we can output. So what over here just try to show, you can initiate a queue, is it, with some other sequence. Okay, what the next one show is DAC. So this is double-ended queue. And in collection, this is also an interface. Okay, so you can add at the front also, not just at back. You can also remove at the back, remove at the front. Okay, so that's why we call it double-ended. And you can initiate with a redac, okay, to create the concrete one. So then here it's we add, that you can also add first or add last. Then we can see the output, okay. So this part is pretty straightforward, okay. So we complete this example, and the last example in this unit is regarding queue and stack. Let's take a look, okay. And for this queue and stack, we still use that book class. For this book class, we implement the clonable interface and the comparable interface, okay. And here is queue and stack. And this time we use queue and stack from Java collection. So you need to import them from Java library. And same thing for the linked list, okay, they all belong to Java utility package. So we are basically already saw the applications with queue and stack in our previous chapter discussion, okay, so here just a quick review, okay, to get more idea. So for queue, in this case, we are going to create a book queue. So this queue is generic. So we specify, plug in the type parameter as book, okay, and create user linked list. So that's always. Then we just add. So this add will add at the back, okay, like the in-queue operation. Okay, and here we create a new book and we also add it. That's it. And then we can also call the remove. So the remove is remove at the front. So this is like the DAC or a DQ operation. Okay, so remove at the front. Okay, but the remove method throws exception if the queue is empty. If you recall previous, we also learned poll. You can also use poll to remove from front. Okay, but the difference between poll and remove is poll will return null if the queue is empty. So that's a difference between these two. So it depends which one you should use, then it depends on your application. If you wanted to handle exception in your code, then you can choose remove. If you want to take care of the null return value, then you use poll, okay? And we can also, if you want to retrieve element, okay, so we call it an element method. And element, it will not remove, okay, it will just return, okay. And also it can throw exception if queue is empty. So that's a difference between this one and the pick operation. The pick operation also retrieve the front item, okay, and also without removing, but it returns null if there is no such element exist. Okay, so just be careful. There are two sets you can use, okay. One set is it can raise exception. The other set is return null. Null value, okay, so depends. Okay, and in Q, it also has a search method. So the contain basically is a search method. Okay, if the specified item in some collection, and the contains basically from that collection interface, if you recall. Okay, and then because linked list is a concrete class, so it implements this contains method. Okay. Okay, and we can also do for each loop with Q. Okay, why? Because collection anyway is also a sub-interface of iterable. Is it iterable? And it has that iterator method. So linked list implement this iterator method. That's why you can do the for each loop. Okay. Okay, so that's regarding Q. And then next, we can also use the stack. Be careful, okay, stack is a concrete class. Not like Q, okay, in Java, okay, it's a concrete class. So here so you call push. Push is add that to the top, okay, so quite familiar. And you can also directly output a stack. And then over here for stack class itself also has a search method. Okay, and the search method is that it returns the index of the element count from the top. Okay, if it returns -1, that means the item is not in the stack. Okay, so you have the specific search method with the stack. And for stack, if you want to remove, you can only remove at the top. Is it? So the pop will remove at the top. And at the same time, it will also return the top item. Is it? That's why over here, when you do .pop, it also returns the top item. And this also throws the exception. Okay, so, and we can also have pick. Pick is just retrieve the item. Okay, so it's a get operation. Okay. And for stack class itself, it also has the for each method. Okay, so you can also loop through a stack using this for each method. And within it, you just plug in. So this implementation is a lambda expression. Okay, so it's a pretty straightforward one. Okay, so that's all regarding Java collection. Okay, so just remember in this unit, we learned Java collection, hierarchy, okay, so just so how the inheritance works, is it in Java collection? Both basically it's about different, so various data structures. And the data structure can operate on a group, or we call collection of items. Okay, so that's why we say Java collection, is it? And also be careful, because there is another class called collections. Okay, this is a concrete class. And it has a number of static methods. And those static methods provide us general operation so that we don't need to rewrite some algorithm to do like find the maximum, find the minimum, and sorting, like those shuffling, those very general operations. Okay, so it's quite helpful, and it can take all sorts of collection data structures. Okay. Okay, so that's just a general idea about this unit. And then today, what next we will do is we will move to the last unit in this class. Okay, so the last part in this class is about secure coding. And secure coding itself has a lot of topics, okay? And we cannot go over all of them. So we just pick some of them to discuss, okay? And there are two nice resources. One is from official Java website, and I posted on our course website. That one is not as detailed as the SEI one. The SEI, cert coding standard for Java. Okay, and here it gives us detailed explanation about the secure coding related rules, and also there are also some examples. Okay, and here if you check this website, it has rules for different languages. What we care here is about Java. Okay, and for Java, let's see. If you take a look for the Java, there are quite a number of rules. Okay, and yeah, you can like read them in your spare time. Okay, for all of the rules, but we will start with rule number 5. Okay, about object orientation. Okay, and under this rule 5, there are 12 other rules, okay, sub rules, and we are not going to go over all of them. We pick some of them to discuss, okay, and based on our knowledge, majority of them we should be able to understand now. Okay, so the first one is about the accessibility of fields, and for this one, if you recall, when we learn OOP, we have the concept called encapsulation, that information hiding. So basically it's regarding the private keyword, okay, the visibility. Or accessibility, is that about instance variables. And over here they call it invariance, is that okay, and generally we don't recommend. So here it shows non-compliant code. So here you have a class. This is a class instance variable, and you make it public. This, normally we don't recommend this, is it? So we should change it to private, is it? So that's a very, very general, that we already learned this. So make it as private, okay? And also we need to be careful is here. Suppose, let's probably like this. So assuming you have some array list, so private, probably an array list. Suppose we call it a book, is it a book, ARR, is it? And then in your constructor, you can initiate it, is it? So here the idea is that this one is not, it's primitive data type. Data type, instance variable. Okay, so you have the accessors and you directly return it. So that's fine. Okay, that's allowed because you have no way to modify it unless you use the set mutators, is it? But for the mutable ones, assuming here, then you have a method, you call it public array list and book, and you call it get array book. Is it? Then within it, you do this, return book ARR. Okay, then over here, there is a huge issue. Is it? Because the purpose of this should be protected. So it's not accessible outside. It's only accessible within the class. But then over here, you set public, you get, you return. Is it? Then you make it public accessible. And if you make it public accessible, then people can change it. Is it? ARR, maybe they can do add some malicious element. And you don't want that to be in this array list, is it? So that's not a good design. Okay, in this case, we need to be very careful because over here, this hash map we haven't learned, is it? And so then in that case, how we deal with that, okay? So like the similar concept, is it? So then the idea here, this is similar, is it? So array is also mutable. Mutable. Yeah, array is also mutable instance variable. Is it? If it is mutable instance variable, and if we do want to prevent it to be modified, the way to do it, we can make it static and final. Okay, so this is not always the case. Okay, this is one approach to prevent it to be modified. So you can make it as static and final. Then nobody can change it. Another approach is sometimes you may say, I do want to maybe read the value, not write, not modify the value. Is it? How are we going to do it? And also you already make it as static and final. Is it? Then the way to do it, you can call clone, but also make sure this clone should be a deep copy. Okay, especially for the case, like suppose here is an array list, like of a book, is it? And maybe you do that new array list. And then you add it, is it? Then over here, okay, just be careful if you just call ARR book dot clone. That is not a true deep copy. If you recall our class discussion, that's not. Okay, the best way is you create a new array list and then do one by. You can call, if you recall, array list to anyone belongs to collection. Is it to implement the collection? Collection has a method called add all. Add all, is it? So the way to recommend is you can create an array list of book. So suppose I call it copy, is it? Then you first do new array list. Okay, you create a copy, and then what the copy does is the copy can do the add all. Is it add all? Then you can pass in this array book. You pass it in. Is it? And this is going to be in its own memory location and with each individual book. Is it? And also be careful, there are multiple levels. If you don't want to share the book, then you also need to do each book clone. Okay, so make sure the multiple levels, it depends on the situation. Okay, you need to do the analysis. Okay, so anyway, so that's all regarding mutable ones. And there is another compliant solution is we can also use unmodified wrappers. Okay, because we already learned collections as a class. In collections, there is a method called unmodifiable list. Okay, and you can also, so this is an array, is it? And you do want to return it, is it? Then you can call the unmodified and then plug in with the mutable ones. So whatever this return, it won't impact the original one. Okay, so these two then will not impact each other. Okay, so that's the difference between these two, okay? And we can take a look at that unmodifiable, is it? And if we go to this, scrolling, quick scrolling. So the Java collections, okay, it's a class, is it? And the class, if you recall, it previously what we learned is something like a binary search, is it? And we also learned the method called max and minimum, is it? And we also saw the method shuffle and the sorting, is it, with this collections. But if you take a more close look, you see it also has this unmodifiable list method. Okay, so anyway, all sorts of unmodifiable. And what it returns some data structure, is it? In this case, it returns a list. So let's take a look at this one. So this unmodifiable list, is it? It can take in whatever class that implements the list interface. Then it returns something, as it's a list basically. And over here, and why we see this won't impact the original, because it returns unmodified be careful, it's a view of this list. It's just a view. Okay, so you can only see it. You cannot, it's read only. You cannot modify it. Okay, so it will not allow you to modify. Is it? Because over here it says any attempt to modify, it will result in supported exception. Okay, so you can also use this unmodified to achieve that goal. Okay, regarding this rule. Okay, so that's the first rule. Let's see, then we can take a look at the second rule. Okay, the second rule for OOP is regarding we need to preserve dependency in inheritance. Okay, we have superclass and subclass, is it? But sometimes you may change your superclass, but to be careful, okay, you need to preserve the dependency of the subclass. Okay, so let's see the example to have some better understanding of this. So here to discuss, this is incompliant. So we have an account class. Within the account class, we have some instance variable. This is primitive called balance. Okay, it does meet the encapsulation rule. And we have this withdraw method. Okay, so it's just did some subtract some amount of money from the balance. Okay, so not a lot of thing. And then we have this bank account. This bank account is a subclass of superclass account. Is it? So over here to override that withdraw method for bank account object, if you want to withdraw, you first need to do security check. Okay, and it provide a security check method. Okay, and this method is also a final method. If a method is a final method, then subclass cannot override. Okay, be careful here. So anyway, it's going to do some account management check, security check. If it didn't pass, then you cannot withdraw. Otherwise, it will do the withdraw if it passes the security check. Okay, and then you may ask, sounds everything is okay, is it? Sounds everything, what's the problem? So let's see here. Okay, so over here, so this account we create with a subclass. That is fine. Is it? Because this is a superclass. The variable type is superclass, but the object basically it's a subclass object. Is it? And then you call the withdraw. Is it? When we call the withdraw, it will do the security check. Is it? It will do the security because it is a subclass object. Okay, subject class object. So that is fine. Okay, so be careful here. Okay, this withdraw is subclasses. Okay, so this is involved, if you recall, inheritance and OOP's polymorphism, dynamic binding, etc. Polymorphism, the dynamic binding. Okay, so, okay, and then, so here, let's see. Then here we update superclass. So we add, so this add a new method. and we call it overdraft. Okay, we call it overdraft. So anyway, it's going to do something. And then the bank account subclass, we didn't do any change. Okay, and then let's see. So now this account we create with bank account. Is it? Then we call withdraw. So over here, the security get checked. Is it? So security checked. And you may think, okay, I already passed the security check. Is it? I pass a security check. And then I do the overdraft. Is it? I do the overdraft. So that should work. Is it? Okay, then let's see. There may be an issue. Okay. So here is a Malayan's client. Okay, so it create a bank account. Then what it did is it just directly go to the overdraft. That's fine, is it? Because this overdraft is super classes. And there is no security check. Is it? So it gets around. As it gets around. So that's going to cause a problem. Okay, so that has a security hole. Is it? So what we can do is the compliant solution is you override the overdraft. Okay, so that you are not allowed, you're not going to allow the bank account object to call the overdraft. Only bank object can call the overdraft. Okay, bank account will not be allowed, or you do some other security check. Is it? So this is regarding we need to preserve the definition. Is it? The relationship between superclass and a subclass. Okay, so we needed to be careful. Okay, and there are some other discussion about the calendar example, and you can take a look, and we can move on to the next one. Okay, the next one is called prevent heap pollution. Okay, so it says a heap pollution. What is the heap pollution? It occurs is that when a variable of a parameterized type reference. If you recall, what is parameterized type reference? It's when we discuss generics. When we discuss the generics unit, is that we mention the parameterized type, but also because this is also means reference type. Okay, so reference an object, and that object is not of that parameterized type. Then there is going to be an issue. Okay, we call it a heap pollution. So let's take a look at example to have better understanding. Okay, so let's see. This is a class we define. Anyway, within it, we define some static method. This static method, it has two parameters. Okay, and if you take a close look, this one, the list interface, it's defined in the library. It's a generic one. Is it? But here, we didn't specify the type. Is it? We didn't specify the type. Okay, then it may cause issue here. So here, you create a string list. Okay, this is a string list. And then you call this method. This method you plug in with this list. This list is string. And then the second parameter this time is an integer. That's fine because the integer is a subclass of object. But when you call the add, there is going to be a problem. Is it? So there is a cap. You will have the class cast exception. So over here, we have the heap pollution. Okay, so this is not a good idea. That's why we discuss generics. Okay. Okay, then what we recommend is if you specify the type, is it? Then if over here, we also, so the type matches, is it? So this type matches. So then there is no problem. So this is parameterized collection, okay. And then how about some legacy code? Is it? Because in legacy code, it doesn't have generic. Is it? So this may be the generic code. Then how are we going to deal with that situation? If you do have an integer, you want to call that method. So here it shows, so we create a string array list. This is string array list. And then what over here is for that collections class, there is a method called checked list. And then you can do the check. Okay, so for this, what it returns is a data structure. That data structure's type needed to meet whatever you specify. So here it says, okay, whatever the return must be a string list. If it is not a string list, it will complain. So this time, if you add this 42, then it won't allow you to do that. It will explicitly tell you something is wrong. Okay, so you can also do this way. Okay, this as a compiler, then will throw. Okay, and the code will fill. Okay, so that's a way we can get around with it. Okay, and there is here it shows more regarding that issue. That so this method is not a generic, but if you recall, this method is a generic method. As it is a generic method. Okay, and then to make this more consistent, is it why we also change this method also to a generic method? Is it? So for the parameterized collection, we also make it generic so that we can avoid that kind of issue. Okay. So this is regarding heap pollution. And then next, let's see. So this is for mutable class. We need to provide some deep copy functionality, okay? So that when we allow passing instance to untrusted code, we can make sure it is safe. Okay, so let's take a look at example to see what the idea is. Basically, previously, we also kind of touched this concept, okay? So anyway, so here we have a class. This class has some instance variable date. It's private, so that's fine, is it? So this meet rule 1, is it? So that's fine. Okay, and here it looks fine. Here looks fine, is it? But the problem comes here, this accessor, is it? And you directly return it. So basically here, you break the encapsulation rule. Is it? Because you define the file, you try to hide it, but now it's public and you return it. And it's mutable, and date is mutable. So everyone can access it, can also change it. If you do string, that's fine because string is immutable. So if the class is immutable, that's fine. Okay. So then you may say, how then are we handled? We do want to return the date, that. So in that case, you create a deep copy, okay? Create a deep copy and return it. That, then that can avoid the problem. Okay, and the other way here it mentions is, in this case, we make it also as final. So that means you shouldn't edit it. That's it, you shouldn't edit it. And yeah, so we can also try with this, okay. You can also make a method, static method, is it? And for this static method, you call it get instance. As a get instance. Then did you see? You call this new, is it? So this new then will create a distinguished copy on heap. Okay, and you can pass in whatever the information you wanted to create with the new object, is it? So that's also an approach. And the clone we already discussed, is it, with the get method. For set method, you can also do the clone, is it, to do the clone. Okay, and so let's see here. So regarding the clone method itself, is it itself, then over here there is another minor thing we also needed to be careful is like for this class, is it? This is also a final class, so that means you cannot extend it as a subclass. And for this clone method, what it does is it first call, because this field is a mutable field. So you need to have a deep copy of the field. Is it? Then, did you see here? You call classes constructor to create a deep copy. Is it? The deep copy with specified values. Okay, and then you return this one. So then this is going to be a real deep copy. Okay, so we need to be careful about the deep copy concept. Okay, and there are more discussions, and we can just read it more after class. And now it's 10:50, so we can